Hello, Xinova Network. Thank you for joining us for our first opportunity webinar of the year. My name is Shivani Ludwig. I'm an Innovation Development Manager at Xinova. I'm also the manager of this particular RFI, or Request for Invention, called Rinse and Reuse. We launched this RFI a couple weeks ago now on January 23rd, and it's open for another couple of months until April 24th. So today I'll be discussing this RFI and taking some of your questions at the end of the presentation. As always, you can submit questions throughout the presentation and at the end using the Q&A button on your screen. If you have specific ideas for discussion, I recommend that you send those to us using the chat feature or the pink circle on the bottom right corner of our website. That's a great way to reach anybody at Xinova. You can also reach out to me directly using the email address on this screen if you have specific ideas. I highly encourage that. It's great to get feedback before you write out a full solution report. So the story of this RFI begins with potatoes. PepsiCo's Frito-Lay plants harvest and process potatoes for many snacks, including potato chips, which we're very familiar with. This begins, of course, with washing and peeling the potatoes. So they're loaded into a hopper, then washed to remove dirt and debris, and then scrubbed with high-pressure spray to remove that potato peel. This is made possible with special kinds of potatoes where the skin is more easily removed for this. And so given the large scale of this process, a lot of plants are already reusing rinse water to reduce costs. On average, Frito-Lay plants are able to reuse the rinse water about 5 times. Their number of plants are really aiming to make this more efficient. And so that's really the goal of this of this RFI. It's the rinse water. So the rinse water is very turbid, as you can imagine. The total suspended solid count is 4,000 to 5,000 parts per million. And this contains a number of things from sugars and starches, finely ground potato peels, dirt particles, sand, small stones, and of course microbes, up to 10 to the 10 CFU per mil, which is quite high. And the microbes are the key issue here. So the other particles, not as much of a concern when it comes to reusing water, but the water has to be disinfected before it can be reused, down to at most 10 to the 3 CFU per mil. However, many methods that you use for disinfecting water generally don't work if the water is this turbid. So common inexpensive methods such as UV and ozone require that the water be filtered first. So PepsiCo's current method for treating water looks something like this. And it begins first with chemical flocculation, where they use a metal salt such as aluminum to coagulate all of the various solids. Then that water is separated via decantation, and that's followed by sanitization using ozone and UV. And all of these are very well established methods. UV sanitization, ozone, decanting, even chemical flocculation, all of these are well established for this, and that is the reason PepsiCo is using this method. Currently, given the scale they're operating at, given what they're looking for right now, that's most cost efficient, but it still does not address all of their problems. For starters, that first step generates a chemical sludge, and disposal of that sludge is costly, and it's not ideal to have to create that kind of waste from this. It's also still a multi-step process, and it would be ideal to reduce the number of steps, increase the number of reuse cycles, and increase the amount of water that can be reused with each cycle. So that's the challenge. We're looking for a more efficient rinse water treatment. So if we look at the bottom, shows the method as it currently is. In the ideal world, and these are solutions we're looking for, we would want to be able to eliminate those first 2 steps. So essentially reduce the microbial load of the water by up to 7 log without requiring significant TSS reduction. So that's a big challenge. It would be a fantastic invention to be able to do this, and absolutely that is within the scope. Given that that is challenging, we're also looking for solutions that essentially make the process simpler, reduce some costs. For example, the steps before sanitation to reduce the solids could be less costly, for example. Maybe you'll require just one step instead of two, not result in chemical sludge. All of these would be improvements on the current process. Keep in mind, though, that they have said that conventional water treatment methods, as you can imagine, there are many, many existing methods. Many of those are too complex for this application. So when we're looking at the motivation for doing this, it's we touched on several of these factors. So the first is cost savings. The fresh water supply is an increasingly stressed resource. So the acquisition costs for that are increasing. And so that naturally feeds a need for more efficient water usage. A more efficient water treatment system also allows for a smaller footprint of these facilities and some operational cost savings. And of course, disposal of the chemical sludge itself is a costly process, so eliminating that would result in some savings too. The bigger picture, of course, is in water savings. So increased cycles of water reuse for this application alone could save over 2 billion liters of water in Frito-Lay plants in North America. Keep in mind that they are not looking at just North America. They are looking to implement solutions globally. And so this could have significant impacts when it comes to water sustainability. So with that, I'll get to the invention must-haves. So along with being inventive solutions, solutions to this RFI have to achieve the following criteria. So of course, first and foremost, it has to be able to reduce the microbial load. So the 7-log reduction can be a tall order, up to 7-log reduction to get down to the 10 to the 2 to 10 to the 3 CFU per mil. But we ask that you look at solutions where this can at least be possible within the realm of feasibility. If you can achieve 4-log reduction, that should be the bare minimum. We're looking for solutions that, of course, are effective with a high suspended solid count. So that not only means that methods for reducing the count, filtration, and so on would work at these concentrations, but also that if you're looking at methods for disinfecting turbid water, it should work at those concentrations. Solutions should be able to operate at the industrial scale of 75 gallons per minute with a continuous process flow. The next part, I think, is the most challenging. There are many solutions out there for treating water, but the most challenging part of the solution is the cost parameters. So the target capital must be $750,000 US or less, and the operating expenses must be within $35,000 per year. So these are fairly stringent because more expensive solutions would not result in any cost savings comparison to what they're currently doing. So I would suggest when you're submitting solutions, please include any information on why you believe your solution would fall within those cost constraints. This might include any specific numbers if you do have them, maybe a comparison to similar equipment or operations where you do have known costs. Anything you have that could help us gauge the cost of this would be really helpful. Lastly, we would want the solution to enable at least 7 cycles of process water reuse. So I wanted to share a few examples of ideas that would be within scope. In discussing other chemical-based solutions, PepsiCo mentioned that peroxide-containing compounds, chloramine, both of these are fair game. We're not limited to these. These are just some ideas that were mentioned by Pepsi. Non-chemical solutions, including membranes or physical methods for separating compounds, are all within scope. When it comes to sanitation, methods beyond UV and ozone are within scope. We're wide open to any method to sanitize, especially if you're tackling the challenge of sanitizing with turbid water. If it is okay to still use UV or ozone in your solution, but keep in mind that the solution must be novel and that these methods don't work, of course, with turbid water. And so we would need to propose a full system that tackles that issue too. And lastly, these are just a few ideas. They aren't, these don't have any higher preference over other ideas. All of these should still meet the must-haves from the previous slide. They aren't necessarily guaranteed to do that. They're just a few solutions to give you an idea of the scope of what would be acceptable. So some of Xinova's previous RFIs have touched on similar topics related to water sanitization. So I really wanted to emphasize what's considered out of scope for this RFI. We're not looking for solutions utilizing high heat, such as pasteurization. We also can't work with solutions that involve any agents that may raise regulatory concerns, both for the potatoes and for the reuse of processed water. On a similar note, we also can't accept solutions that use any methods that would result in undesirable byproducts. So for example, if you're proposing a chemical-based solution, keep in mind all of the various compounds that are in the rinsed water, and if any interaction would result in something undesirable, something that might raise regulatory concerns, then that would be a problem. If you do have questions about either of those two categories, whether something would raise regulatory concerns or not, please just contact us and we can help you with that. Lastly, PepsiCo specifically mentioned that chlorine dioxide is out of scope. For them, its use would require significantly more testing before it can be approved. It's just a higher, more of an uphill battle for that one. So with that, open to taking questions. As I said at the start, you can submit them via the Q&A button, which you can find at the top of your screen on the computer and I believe at the bottom of your screen on your phone if you're attending through that. You do have the ability to send questions anonymously, but again, if you have any specific ideas, if you're asking about, is idea X okay, I would recommend emailing us with that instead, and we can discuss that in more detail.